now we're going to look at calculating some logarithms. When we evaluate logarithms, it means we want to find the value of it. We want to work that problem out. This says take the logarithm of 4. Okay, now we have a log button and a natural log button in the calculator. Here, this log, remember, is log base 10. If you don't see a base there, it's understood to be a base of 10. So in our calculator, we have both the log and the natural log button. We use this if it's a base of 10, log. We use natural log if it's a base of e. Okay. So to calculate this problem, we're going to just type log of 4. So in the parentheses there, I'm going to put the 4 and close the parentheses. And then it gives me the decimal value. Here, this problem asked me to round it to 3 decimal places, so I get 0.602. Now the next problem, natural log of 84. So now I do the LN button. LN of 84 and close the parentheses. That gives me 4.431. If I'm going to round to 3 decimal places, 4.431. Okay. And then let's see the log. So I go back to the LOG button of 0.001. Gives me -3. I don't have to round that answer. Now let's look at some properties. Basic properties that are just based on the definition of these exponentials that we're based on. When you have the log and the base and the argument are the same number, then it's going to always equal 1. That's something like the log base 2 of 2. So you ask yourself there, 2 to what power gives you 2? Well, 2 to what power gives you 2 would be a 1. Any base, if you take the logarithm with any base of 1, you get 0. Because anything to the 0 power is 1. If you have the log and the base is b, and the argument is b to a power, then that power is going to be your answer. Because remember, the logarithm is taking b to what power gives you this. Well, it would obviously be the power. Now, if the b is the base, and the log base b is in the exponent of this b, then the log base b and b to that power end up kind of undoing each other, and you're left with just the x. And then one final property here, if we have two numbers that are equal and we take the log of those two numbers, they'll still be equal. Okay, so that property we'll use when we solve equations. So let's look at some statements here, different bases, and just what these mean and how we can get some values without using our calculator here. So first off, log base 2 of 16. Let me move this. Log base 2 of 16. Now what does that really mean? That means 2 to what power gives me 16. So when I answer that, 2 to what power gives me 16, that power, let's see, I'm going to use my calculator to get that, just to try different values. It says without using a calculator, and what that really means is without your buttons there in the calculator. If I do 2 squared, I get 4. If I do 2 cubed, I get 8. If I do 2 to the 4th power, I get 16. So that tells me my answer here is 16. I already have it written out there. Okay. So the 16 means the power that I had to raise 2 to get that 16 is 4. Now let's look at the next one. Log base 5 of 125. So now I want to try different numbers. 5 squared, 5 cubed is 125. So that means this would be 3. Now I want 10 to what power is 100. Well, I know 10 to the first power is 10, but 10 squared is 100, so my power there would be 2. Now for each of these, I will have some more to look at. 2 to what power gives you 1/8? Now let's think about this one a little bit. 2 to what power gives you 1/8? My 8 is in the denominator, so that means my power will have to be negative. And since 2 cubed is 8, our answer here is going to be a negative 3 for the exponent. If 2 cubed is 8, 2 to the negative third power is going to give you 1/8. Now, log base 2 of 1. Log base 2 of 1, that's right. 2 to what power gives you 1? Anything to the 0 power gives you 1. And let's look at natural log and e. We said that natural log is base e. So that means e to what power gives you e squared? Well, that's just going to be a 2. Now your calculator may have what is called a change of base button. Okay. If it has a change of base button, you might not use this rule very often, but you still need to be familiar with it. Before we had these graphing calculators that were so smart and we had to do a lot more things by hand, if we had an expression like the log base 8 of 124, we would have to try to think of 8 to what power gives you 124. And maybe we could think of that exactly and get a decimal, but maybe not. Here, if I tried numbers, 8 to the first power is 8. 8 to the second power is 64. Let's see, if I do 8 to the third power, I get 512. So I skip right over the value of 1024 that I want. So in order to calculate this, we're going to get a value somewhere between 2 and 3. Because it's got to be bigger than 2, but less than 3. So we can do what we call using our change of base formula, in which we calculate with a base of 8 in our calculator the log base 10 of 24 divided by the log base 10 of 8. I don't have a log base 8 button, but I have a log base 10 button. So I could put that in my calculator. Log of 124, close parentheses, divided by log of 8, close the parentheses. And that gives me a value of 2.318. About. Now, I could also change that to logarithms, in which case I would use, not logarithms, natural logs, in which case I would use the natural log of 124, close parentheses, divided by natural log of 8, close parentheses. It gives you the same decimal value. Now, if your calculator has been updated and has this, if you go to the math function, let me go up here, the math button right here. If you go to the math button, in that first column, you don't see it the way it is now. But if you arrow down and keep going down, this little arrow here tells you there's more to see. So keep going down. We see log base. If I use that, if I just press enter on A log base, I now see the base, subscript, and a place to put the number. Kind of looks like this. So I could find this value by putting in a base of 8. And then in the argument space, I would put the 124. And it would give me the 2.3. Again, let me show you the steps. I went to the math key, which is right here. And you can either go down all the way till you find it, or you can go up to option A, log base, and then put in the base of 8 and arrow over to the argument of 124. And it will give you the decimal value for that. Now that base button helps us when we do log graphs. We know that these are inverses of each other. So if we wanted to graph y equals log base 2 of x, that would be the inverse function of y equals 2 to the x power. And we know we're very familiar with the graph of y equals 2 to the x power. Let me get my standard window back. Zoom 6. I pushed the wrong button there. There is my 2 to the x power. But if I want to graph the log base 2 of x, like this, I would need to use either my change of base formula or go to that math key. Let me rid of my math key. Go to my y equals. Go to my math key. And I'm going to go to find log base. And then I'm going to put in 2 for my base. And I'm going to put in x for the argument. Then my graph of my logarithm function looks like that. Remember we said these are inverses of each other? There's the graph. And we talked earlier in the unit about if functions are inverses of each other, that means they're symmetric around the line y equals x, or mirror image. My line's not very straight there. But you can see they are mirror images of each other around that line y equals x.